Hello and welcome back to the Architect's Guide to Salesforce Agentforce 360. In today's episode, we are exploring another exciting hands-on use case, demystifying MCP, aka Model Context Protocol. AI agents are getting smarter every single day, but here's the real challenge we are all facing. How do we control what agents can see, what they are allowed to do, and how they securely connect to enterprise systems at scale? That's exactly what we are unpacking today. In this episode, we are demystifying Model Context Protocol or MCP, why it exists, why it matters, and how Salesforce is leveraging hosted MCP servers to bring enterprise grade trust, governance, and consistency to AI agents. So let's start with the basics firstly. What is MCP, Model Context Protocol? MCP is an open protocol that standardizes how AI agents securely connect to external tools, APIs, and data sources. It was originally introduced by Anthropic in late 2024 and has since gained broad industry support. Today, MCP is supported by platforms like OpenAI, Google, Microsoft, and now Salesforce as well. A simple way to think about MCP is like a USB-C for AI agents. USB-C standardizes how devices connect to computers. MCP standardizes how AI models connect to data, tools, and services. So how MCP works, the architecture. MCP is built around three core components. Firstly, the MCP server, the capability provider, which is a backend service that exposes tools, data, and actions. All capabilities are defined in a standard MCP format. As an example, the Salesforce-Hosted MCP Server, which is currently a beta service. Secondly, MCP host, the runtime environment. The environment where AI model actually runs, responsible for managing MCP connections and execution. Think of it as the AI's operating environment. And thirdly, the MCP client, the requester or the tool invoker. The component that calls MCP tools using the protocol, commonly embedded in a developer tool. As an example, VS Code extension like GitHub Copilot Chat. Together, these three components create a clean separation of concerns, capability, execution, and invocation. So let's try to understand why do we need an MCP. The biggest limitation of AI right now, it's not the intelligence, but it is the context. For developers, MCP dramatically reduces integration complexity. No more one-off connectors or fragile middleware. It allows faster development, clean architecture for connecting AI applications or agents. For AI agents, MCP provides access to a pluggable ecosystem of tools and data sources, which is consistent, governed capabilities to allow better answers, safer actions, and improve end-user experiences. Let's try to understand what is the Salesforce-hosted MCP servers are. Now, this is where it gets really interesting for our Salesforce listeners. Salesforce-hosted MCP servers give AI assistants a governed, standard way to talk to Salesforce data and services. Salesforce-hosted MCP servers run inside your org and safely expose selected capabilities as MCP tools for compatible AI clients such as Agentforce, Claude, Cursor, etc. And yes, it is currently in beta with broad availability expected as the platform matures. Instead of building and maintaining complex middleware, you can now host an MCP server directly within Salesforce's infrastructure. To bring this concept to life, we'll walk through its step-by-step demonstration. Let's now jump onto the configuration. Firstly, let's enable the MCP beta feature. To enable the Salesforce-hosted MCP servers beta service, follow the below steps. From setup, in the quick find box, enter user interface and select user interface. On the user interface page, select enable MCP service beta. Secondly, let's ensure API access is enabled. So let's navigate to setup profiles, your profile as an example, system permissions. Make sure API is enabled. Without this, no external application can access Salesforce. Thirdly, let's set up the VS Code IDE as the MCP host. Let's open VS Code
authenticate to your Salesforce default org. And now let's configure and run the local MCP server. In your Salesforce DX project root, create a .vs Code folder and add a file called mcp.json. Here's an example in VS Code mcp.json file. This uses the default target org that we have already connected in the previous step. And what do these parameters mean? -y means it automatically installs the npm package if needed without asking the confirmation as part of the npx command. At Salesforce/MCP at latest specifies the Salesforce MCP package to use. --orgs is a required attribute and it specifies which authorized Salesforce orgs the server can access. --toolsets. This specifies which groups of tools the AI agent can use. Using fewer toolset reduces the AI's context and improves performance. Some of the common values includes orgs, metadata, data, users, testing, code analyzer, Apex performance, LWC, and all. Once the configuration is ready, let's start the server. In VS Code, let's click Command-Shift-T, MCP, list servers, Salesforce MCP, and start the server. Alright, now let's test with an MCP client. Once the server is running, an MCP-aware AI agent like GitHub Copilot in agent mode can act as a MCP client. Let's install the GitHub Copilot VS Code extension. And that's it with the setup. Now it's time to put everything we have built into action. Let's test the final configuration. Let's start the conversation by submitting the following prompts in the Copilot chat window. Firstly, let's ask query the last 5 accounts in my org. So the query, it runs against the Salesforce MCP local server, and here is the output. So it identifies the top 5 accounts and returns the response. As a second example, let's run this prompt. Let's look at the account object in my Salesforce org and tell me which fields are required to create an account. And this is a org specific request. So depending on the org, there might be different levels of required fields. So let's look at the response. Alright, so it says it runs against the MCP to my default org and it identifies these fields needs to be provided by when creating an account. The name is a required field, the owner ID, and the currency ISO code. Voila! While large language models are non-deterministic, in this case GitHub Copilot chat acting as an MCP client can now safely execute natural language prompts against your Salesforce org. As an example, requesting for org-specific objects required fields via the VS Code IDE powered by the Salesforce-Hosted MCP Server. And that's it for today's setup. We have gone from concept to configuration and now you have seen MCP in action. Thanks for tuning in and I will see you in the next episode of the Architect's Guide to Salesforce Agentforce 360.